Hi guys, in this specific discussion we're going to look at the concept of the gamma radiation, and from the various characteristics that we had given for the previous two, for the alpha and beta particles, we had mentioned that the alpha particles are basically the helium nucleus, and then for the beta particles it is an electron, and we had given two aspects of the of course for the these decay processes that we had mentioned earlier, as I've said. So therefore we added the beta kind of radiation, and mentioned that for the beta we have two different types of beta decay. We have the beta positive and beta negative respectively. And in this case, the last bit we're going to look at the concept of a gamma, and therefore we would say that this is going to be a form of electromagnetic radiation, which is going to display a very high penetrating power and the source of energy, or rather a form of energy. And in contrast to the first two, then therefore we would say that these are going to be particles, as well as the last one is going to be a form of electromagnetic radiation. So we're going to look at this concept of a gamma radiation in that specific respect, whereby we're going to consider it as a form of radiation. So that is why in our first illustration from the video, I'd given for the illustration, I'd given the beta particle as a particle which was illustrated as that, and I'd given the alpha particle as a particle which was being illustrated by this specific symbol. So therefore we described this one as an electron, and as we said that an electron has got mass, so therefore it's going to be considered as a particle from the wave-particle duality concept. And we had said that for this helium nuclei, then therefore we're going to have it as having a mass number and atomic number given as such. So in this specific case, I've given an illustration for the radiation which I referred to as the gamma radiation, which is of course going to be illustrated as such. So therefore, in us describing its specific characteristic, then therefore we're going to look at its penetration power, the aspect of intensity and other areas, and the effect it's going to have on other areas or other elements, and from the experimental aspect. And in this particular case as well, we can just have an illustration of the alpha radiation from the equation form that we had given for the first two. Therefore, we can use a specific example for this one for the isotope of uranium-235, which of course is going to display this aspect of emission of gamma radiation to give another isotope of thorium. Therefore, this is going to be illustrated as such. So therefore, if we try to look at this, we can be able to just give a simple example for cobalt. For this specific type of radiation, I mentioned the concept of a neutrino and a neutrino, of course, which I'm not going to involve in this specific case. So let me use the concept of a cobalt 6027, which is going to transit to cobalt 6028, and this is going to be accompanied by a release of this specific beta and negative, and then there's going to be gamma radiation, which is those specific zeros at this specific point. So this is going to be a general equation for the emission of gamma radiation, apart from other examples which we are going to give, which is going to be achieved from the decay of cobalt 60, which is going to be given as such. So therefore, we are going to look at the various applications of these specific processes, but of essence for us is to try and find out how we can be able to describe them in terms of these specific equations. And the various products, take note of the various products which are going to be formed, of course, from these various decay processes as I've mentioned. So in our next discussion, we're going to look at the concept of the neutron, of course, a proton ratio, particularly in the nucleus, as we had mentioned, the concept of stability that is going to assist us to pinpoint which kind of radioactive decay process is going to be experienced by various isotopes, so that we had, of course, mentioned insofar as the concept of radioactive decay is concerned. So in this specific case, I'd like to invite us to check on our description boxes for various links for other related videos which are going to assist us, of course, in trying to describe this. So our remaining part of the radioactive decay processes, we're going to look at them in other videos, so especially that is concerning the concept of electron capture and other areas that we have not mentioned, of course, which are going to involve the transition, other transitions, of course, like the positron production, etc. So catch us in our next videos. We're going to look at another process of a radioactive decay process, and of course, these are going to assist us in trying to interpret the various radioactive decay series, particularly for the 3 natural ones and the artificial one that I had mentioned, of course, which I'm going to give in terms of a display for us for easy understanding. So that is it for now, guys. Bye. God bless you. Catch us in our next video.